All right, let's get into something a little controversial today. We're going to take a look at a pretty provocative critique of modern physics. It's an argument that says some of the most famous ideas out there, we're talking black holes, the Big Bang, might just be built on some seriously shaky ground. So this explainer is all about digging into that skeptical point of view. And yeah, right off the bat, you can see the author of our source material is not pulling any punches. This one line really sets the tone for everything we're about to cover. It's a deep skepticism about theories that, let's be honest, are often presented to us as totally settled science. So what's the deal? Why would anyone call these huge ideas nonsense? So, where does this all start? Well, the whole critique really hinges on one big idea. The author suggests that our most important theories in physics, the ones that are the bedrock of our understanding, are all missing a single, absolutely crucial element. And look, we're not just talking about some fringe ideas on the edge of science here. The argument is that even the absolute titans of physics, Einstein's general relativity and the super weird world of quantum mechanics, suffer from the exact same fundamental flaw. So, what is this missing piece? And here it is. It all boils down to this one concept, a material description. Think about it like this. It's one thing to know the rules of a game, the elegant math, the symmetries, but it's another thing entirely to know what the ball is made of, what the players are made of, the actual physical stuff that's in motion. That's what the author is demanding, an explanation of the underlying machinery. Okay, so now let's see what happens when we take this idea, this material description test, and apply it to some of the biggest theories out there. The author basically uses it as a yardstick to measure what we think we know. Now this right here, this is Exhibit A for the author's case. You've got these two powerhouse theories, right? General relativity, which runs the show for huge things like stars and galaxies. Then you have quantum mechanics, which is all about the tiny stuff, atoms and particles. Both are incredibly successful. But here's the kicker. They just don't play nice together. They are totally, fundamentally incompatible. And for the author, that's a massive red flag. It screams that we're missing the real underlying material picture. And that brings us to the author's main event, the concept that really goes under the microscope, the black hole. We all know the basic story. We've seen the documentaries, right? A giant star collapses, gravity goes nuts, and it gets so strong that nothing, not even light, can get out. It's a simple, pretty powerful image. But here's the thing. The author says that while that story sounds super clear on paper, it's actually hiding a ton of really weird and unanswered questions. It's sold as being straightforward, but the actual physics, it gets complicated fast. And this is the central challenge. A whole star collapses. So where does all that matter go? The theories point to something called a singularity, a point of infinite density where all that stuff just kind of vanishes. Now, even the experts will admit that singularities probably don't happen in the real world. But according to the author, they don't have a good alternative for where that star actually went. Okay, so this is a really important point to make. This critique isn't about just throwing out all the evidence. The author totally accepts the observations. We do see these huge amounts of energy packed into tiny spaces. We see light getting bent by massive objects. We've detected gravitational waves. The argument isn't about the data. It's about how we explain that data. And this gets right back to the core critique. When physicists try to explain what's really happening inside a black hole, the answers get super abstract. They start talking in terms of pure geometry, or information theory, or thermodynamics. For the author, that's the whole problem. These aren't descriptions of physical machinery. They're not made of material stuff. Exactly. The point is that the explanations have become so abstract, so exotic, that they've lost their physical intuition. It's no longer about what's physically there, but about complex mathematics that, the author argues, have become totally detached from reality. All right, so black holes are the main target, but this skeptical lens gets pointed at a whole bunch of other famous ideas in modern cosmology too. The Big Bang theory gets pretty much the same treatment. Without a material description for what banged or how it happened, the author argues it's less a scientific theory and more of a religious question. The physics is compared to building this beautiful, magnificent cathedral, but it's just floating up in the sky with no foundation on the ground. And the dismissals just keep on coming for these other popular ideas. You can see the pattern here. Dark matter and dark energy are framed as just unnecessary mathematical patches that exist on paper. Others, like wormholes and time travel, are just dismissed as physics nonsense. And these huge, sweeping theories like the multiverse, pure speculation, built on what the author considers to be dubious foundations in the first place. So after all this criticism, what's the ultimate takeaway here? It's not about just tearing everything down, but about pushing for a real change in mindset. And that's really the heart of it. The author's final plea is for humility. Instead of creating these elaborate, untestable stories to explain the universe's biggest mysteries, maybe science should be more comfortable just saying, you know what? We don't know. Admitting our inabilities is presented as the first real step toward genuine progress. And here's the final, sharp-edged summary of the whole argument. The claim is that theoretical physics has strayed from its engineering roots, from building and testing real material things, and has entered a phase of, well, smooth-talking alchemy, where compelling fairy tales and mathematical beauty are valued more than physical, verifiable reality. And that leaves us with this final thought to chew on. Based on this whole skeptical viewpoint, is it possible that the path forward for physics is to focus less on grand abstract theories and more on the tangible, engineering-focused question of what is the underlying machinery? It's a challenging question about the very nature of scientific discovery itself.